In this demo, we are going to show you the capability of NF1208 module to generate digital patterns and change data format on the fly. We know that NF1208 digital module has 8 independent channels with up to 100 MHz vector rate at any frequency. Within each clock cycle, it has 4 programmable timing edges. And by programming these 4 timing edges, we are able to produce formatted outputs per channel. Some example formats include NRZ, RZ, R1, SBH, which represents surrounded by high, etc., etc. And we are able to generate digital data with change on the fly data format. Now let's move on to the LabVIEW application to see the demo. In this demo, we will show you the capability of NF1208 digital I/O module to be able to generate data patterns with different time sets and change the data format on the fly. First, we go to the configuration tab where we can configure the timing formatter of this I/O module. Here, the configuration applies to 4 channels. We first enter a time set that's called NRZ, which means non-return to 0. Here, we have 4 configurable edges. We program the second edge D1 to 5 nanoseconds. We click Add to add this timing set into memory. Now we want to add a second timing set. We choose RZ for this data format. So RZ means return to 0. Here we keep D1 edge unchanged, and we program D2 edge say to 25 nanoseconds. Now we add this time set again. So now we have 2 different time sets in the memory. We are done with the configuration. We go back to the microcode tab to have a look. Here we are having a very simple example to generate 2 different sets of data. First set of data is 1010 with time set 1, which is non-return to 0 time set. The second set of data is 1010, and here we are using time set 2, which is the RZ time set that we have just configured. We download this raw data pattern to the memory of the digital I/O module. Now we go to the last page, bursting. Here we confirm that we want to generate the data pattern vector at 25 MHz. We click OK. Then we select we want to generate the data continuously, and we click bursting button. Now let's move on to the oscilloscope screen to verify the data output. Here on the oscilloscope, we can see the actual signal output from the digital I/O module. We have chosen to display channel 2 and the channel 3 of the digital I/O module output, which is represented by the yellow color curve and the blue color curve on the screen. On the left of the yellow color curve, you can see that we have data 1010. And remember, this is using time set NRZ, non-return to 0. And on the right portion of the yellow color curve, we can see data 1010 as well. However, because the time set we use is RZ means return to 0, it means the data 1 must return to 0 before the cycle ends. In fact, if you remember, based on our configuration in the software, it actually returns to 0 at the edge position of 25 nanoseconds. Similarly, for the blue curve, we have configured to use the same time set as the yellow curve, which means time set 1, non-return to 0, and time set 2, return to 0 at 25 nanoseconds. Therefore, the pulse width of the return to 0 portion of the curve is narrower than the pulse width of the non-return to 0 portion of the curve.